Alright, so this video is the Unit 11G handout, which is what I like to call the goat problem. Um, and this is actually not an uncommon problem that you see. It ties together a bunch of different concepts related to area and perimeter. So the idea is that we're looking at a bird's eye view. So of a barn, and this blue line right here going across is a fence. And I'll label it fence just so we have it. So this thing right here is a fence. The Everything out here is all grass except for the barn. Um, and there's a goat that's tied to the corner of the barn by a 55-foot rope. Now let's see, this is 35 feet, so it'd be a little bit longer than that. So the goat would be maybe like out to about here, right? There's the goat. And this is 55 feet. So I'll draw that back in a little bit, but you get the idea. Okay. So the question is going to be related to where can the goat graze. So the first thing we want to do is sketch the boundary of where the goat can graze. So 55 feet of rope is what he has connected to point A. So if he were to go, say, 55 feet directly this way, so let's see, that's 35 feet, so a little bit longer than that. So he would be able to go that far, 55 feet. And then he could also go 55 feet this way, right? And if he goes 55 feet that way, there's an extra 20 feet left over right here because there's 35 there. So this whole thing here is the 35 plus an extra 20 feet. And if you think about it, well, he could go 55 feet this way, this way, this way, this way. So it forms this semicircle right there, half circle, right? Okay. Well, the 55, he could keep walking around and it would just keep forming this circular shape until he hits the fence right there. So there's that part too. And then the thing that students kind of mess up over on the left side of the picture is they figure, well, it's going to keep going down like this and a hit right there. But the rope is going to catch on the corner of the barn there. So he doesn't really have 55 feet to work with. He can't cut through the barn like that with the 55 foot rope. So instead, he's got 20 feet to work with that catches on the corner. So since this side right here is 25 feet, he's not going to hit all the way at the bottom of the barn there, the bottom corner. He's going to hit it right about there, where this is 20 feet, and the leftover down here is 5 feet. There, I'll kind of do this. 5 feet. Okay. So I'm going to call this region right here region 1. The semicircle on top, I'll call region 2. And those two regions actually aren't too bad to figure out how much area they take up, which is going to be part of question number 2. So question number 2 says find the total grazing area of the goat. So region 2 is just this gigantic semicircle, and region 1 is this sector of another circle right here. So, and then this part over here, I'm actually going to slice into 2 different types of shapes. So if I connect point A to here, that's 55 feet right there. And then the nice thing is this part underneath it is a perfect right triangle. So we can work with that too. So I'm going to call the triangle region 3, and I'll call this piece region 4 right there. So let's find the areas of those 4 regions. So area of region 1. Well, region 1, if you look at it, it's actually a 90-degree sector right there. But notice the radius isn't 55. The radius is actually 20 if I were to keep it going all the way around. So since the central angle is 90 degrees, this is going to be 90 over 360 So it's percentage of the circle's area, and this is a small circle, 20 foot radius. And if you type that all in, then you end up with 314.15926. Let's look at region 2. So here's the center of region 2. It's a half circle. It's 180 degrees right here. So I can use the same kind of formula, but now it's 180 over 360. And notice the radius of the sector for that isn't 20 anymore. It's the full 55 degrees. And if you plug that into a calculator, you're going to end up with 4751.65889. Okay. Let's take a look at 3. Region 3. So 3 is a triangle. So the formula for a triangle is 1/2 base times height. Now I know the height is 25 here. I need the base. Right? So I'm going to write 1/2 base times 25. So the key here is what's the base? Right? So let me do this. We'll figure out the base. Well, it's a right triangle. I know the 25 and I know the 55. So to get the base, I'm going to use Pythag. 25 squared plus b squared equals 55 squared. So let's see, if we work this out a little bit, I could just tell you b squared ends up being 2400, so b will be root 2400. So then this, I'll bubble this here, we'll put that in the cloud kind of, and then I'll shrink it down a little bit. Okay, so then this is going to turn into 1/2 root 2400 times 25, and if you plug that all into a calculator, it comes out to 612.37244. Okay, area 4. So area 4 is a sector as well, and here's its angle, its central angle, so I'm going to call that theta. So I can use a formula like 1 or 2, the theta over 360 times pi r squared. The problem is I need theta. So you can get theta a couple ways. One way would be solve for this angle right here using trig, and then do 90 minus it to get theta, which substitute flag. Whoops. Another thing you could do is solve for theta directly, because notice this line is horizontal. And this line is horizontal. Ooh. So you actually end up, here, let me highlight this. This line and this line are parallel to each other. So you actually end up with the Z shape right here, and this angle where I mark theta is the same as that angle down there. That's also theta. So if I draw triangle 3 by itself here, here's theta. This is 25. This is 55. We know this is also root 2400 down here. And then the angle that we really want is this one right here, but that's also theta. So if I solve for theta, then in using the triangle, then I know my central angle. So let's use the 25 and 55 because those are nicer numbers. This is opposite. This is hypotenuse. So not tan, sorry. Sine theta is going to be 25 over 55. So theta will be sine inverse of that. And if you type this in degree mode on your calculator, you'll end up with theta being 27.03569 degrees. So this thing, all right here, will come in handy when you plug into this formula, theta over 360 times pi r squared, and in this case r is 55. So this theta right here goes there, right? And so we end up with 27.03569 over 360 times pi 55 squared. And if you work all that out, that comes out to about 713.69103. By the way, if you wanted to, you could combine sections 2 and 4 into one gigantic sector that looks like this, where this is 180 plus the 27. So then you just do the 180 plus the 27 over 360 times pi r squared. So you could combine 2 and 4 into one piece if you wanted to. Anyway, okay, so let's go on. What we need now is the sum of all of those 4 regions. So the sum, remember this means sum of, it's the Greek letter S, sum of all the areas is going to be, let's see, this plus this plus this plus that. So if we add up those 4 areas, I'll do area 1 plus area 2 plus area 3 plus area 4. If you add them all up, you end up with 6,391.882. And since the lengths are all feet, this is going to be square feet. Right there. Okay, now let me take this picture and cut and paste it here. Hit copy. And then I'll just paste it right down here so we have it again. All right. So part 2 says, or part C says, find the perimeter of the grazing area. So the perimeter, I'll highlight it in green here. The grazing area that the goat can reach, it's all of this along here. So it's all of the boundary plus this part, plus this part, plus this part, plus that part. Okay, so it's that green outline there. Well, some of those are easy. This part right here is 20. The top of the barn's 35. This side's 25. We already know the root 2400. So I've got 20 plus 35 plus 25 plus root 2400. But then I've got these various arc lengths. So I've got this one right here, which I'll call L1. Or actually, I'll go from this side because this is how I did it in class. This one would be L3. This one right here, I'm going to call L2. And then this arc length right here, I'll call L1. Okay. Well, so I've got to add in L1 plus L2 plus L3 to get the perimeter. Okay. Well, let's figure out what L1, L2, and L3 are. So L1 is not a full circumference. It's a portion of a circumference. It's 90 out of 360%, right? If you turn this into a percentage, that's how much of the circle it takes up, if you think of this circle right there. So I don't want a quarter of the circle's area. Now I want a quarter of the circle's circumference. So I'm going to plug in 2 pi r here, 2 pi 20. Right? So then this comes out to be 31.41593. And then L2, let's see. L2 is half of a circle's circumference, the perimeter. So you can either do half of 2 pi r, or if you wanted to use the formula, it's 180 over 360 times 2 pi r, and in this case r is 55. So then this comes out to be 172.78760. And then L3, that's this little arc right here. Well, we know what theta is now. Theta is 27 degrees. So this is going to be the 27.03569 divided by 360 times 2 pi r, because I don't want a percentage of the area, I want a percentage of the circumference. 2 pi 55. So if you work that out, you end up with 25.95240. Okay, so if we put all these things together, if we put L1 right there, we put L2 right here, we put L3 right there, and you add them all up, then the perimeter, you add up all of these things, right? Then the perimeter ends up coming out to be 359.146 feet. Okay, I hope that helps a little bit, and I'll see you guys soon.